Hello class, welcome to Geometry Lesson 2-4, which is all about slopes of parallel and perpendicular lines. By the end of this lesson, you should be able to use slope to solve problems about parallel and perpendicular lines. This is all pretty much a review from what we did in algebra last year, so hopefully today won't seem so bad. Let's jump in with Theorem 213, which is talking about two non-vertical lines. So that's anything with a slant. So if you look on the left-hand side there with the blue arrow, those are parallel if and only if their slopes are equal. And then on the right-hand side of the screen, we have two vertical lines, the straight up and down. Any two vertical lines are parallel, and I would expand that to any two horizontal lines are also parallel. Okay, so let's talk about the slope of parallel lines. So the slope of parallel lines has to be equal, but how do we find the slope from 2 points? First, let's remember that m is the variable we use to represent our slope. And in order to find slope, we do y2 minus y1 over x2 minus x1. So let's try to find the slope of line K. We know line K goes through those 2 points. So I have xy, xy. So if I start with negative 3 minus 2 over 2 minus negative 2. So I did negative 3 over 2. And then I did 2 minus a negative 2. So negative 3 minus 2 is negative 5, and 2 minus a negative 2 becomes 2 plus 2, or 4. Now let's find the slope of line N. So again, I have negative 2 minus 2 over 4 minus 1. So negative 2 minus 2 is negative 4. 4 minus 1 is 3. Wow, that didn't work well. There we go. So negative 4 over 3. So if we look at the two slopes, I have a negative 5/4 and a negative 4/3. Are those equal? No. So we would say line K is not parallel to line N. Alright, I want you to determine whether lines M and Q are parallel, given that they go through those points. Good luck. Hopefully you ended up with a 1/3 slope for line M and a 2/5 slope for line Q, meaning that those two lines are not parallel. In order to be parallel, they would both have to be 1/3 or both have to be 2/5. Alright, so that's parallel lines. Let's talk about perpendicular lines. So any two non-vertical lines, so again on the left, are perpendicular if and only if the product of their slopes is negative 1. Remember, product means to multiply. So if we multiply their slopes together, we should get to negative 1. Or last year I used the phrase, they should be opposite reciprocals. Okay. And then the second part of the theorem is a vertical line and a horizontal line are perpendicular to each other. Okay? Those would be considered opposite slopes if you have a vertical line and a horizontal line. So let's determine whether lines J and K are perpendicular. So J, if I start with 2 minus 5, and honestly, if you did 5 minus 2, that's okay as well. But if I do 2 minus 5, then I have to do 1 minus negative 1. But if I did 5 minus 2, then I would start with my negative 1, like that. Either way, as long as you're consistent with which point you're starting each line with, you're okay. So I would get negative 3 over 2. And just like this, I get 3 over negative 2. Those are the same exact thing. I just wanted to show you that it doesn't matter what order you choose the points in as long as you're consistent. Just like when we did distance formula, just like when we did midpoint formula, as long as you're consistent, you're okay. Alright, and then let's find the slope of line K. So if I do 4 minus 2 over 0 minus negative 3, 4 minus 2 is 2, 0 minus negative 3 is a positive 3. So my two slopes are 2/3 and negative 3/2. So what I need to do is check them out and see, are these opposite reciprocals of each other? Excuse me. Remember, opposite means that one's positive, one's negative. Reciprocal means that you take the fraction and you flip it upside down. So 2/3, I have a positive, and then I have a negative, so I have the opposite part. And then 2/3 flipped over is 3/2. So you can see I have opposite reciprocals here. But if you're worried about confusing what opposite reciprocals are, you can multiply them. And if I do 2 times negative 3, I have negative 6. 3 times 2 is 6. That simplifies to negative 1. So I can see that they are perpendicular. So I would say, yes, they are perpendicular. Why don't you go ahead and see, our lines H and L perpendicular? Good luck. Hopefully you got a slope of negative 2/3 for line H and a slope of positive 5/2 for L. And you realize that these are not opposite reciprocals of each other, and if you multiply them together, you don't end up at negative 1. They do not equal negative 1. So we can say that they are not perpendicular. All right, now, our last example, we're going to do 2 versions of it, okay? This first example, we're going to write an equation of the line through point P that is parallel to line L. And then next, we'll write an equation of a line through point P that's perpendicular to L. So let's refresh our memory on how to write those equations. So we had something called slope-intercept form last year. Y equals mx plus b. And remember, m is your slope, b is your y-intercept. This is going to be incredibly important for tomorrow's lesson, being able to write these equations. So please make sure you're asking for help if you're even a little bit confused. Okay, so I'm given the equation y equals 1/2 x minus 3. And if I'm looking for something parallel, I am going to keep my slope. So let's write it out. Step 1. Parallel means keep the slope. So I can say that m is going to equal 1/2 x. Or sorry, 1/2. The slope is just the 1/2. It doesn't include the variable. Step 2. I'm going to plug point P in for x and y to solve for b, or my y-intercept. So that would be, I would originally have y equals 1/2 x plus b, but I'm going to plug in point P, which is 4, 1. So my y value is 1. I keep my slope. My x value is 4, and I want to solve for b. So I have 1 equals 1/2 times 4, or 1 equals 2, plus b. Subtract that 2 over, I have negative 1 equals b. So my equation, so I guess step 3 would be solve for b. Or no, I already wrote that in step 2. Sorry. Apparently I'm losing my mind. Step 3, rewrite the equation. So that would be y equals 1/2, so you keep your slope, x minus 1. You insert that b value into your new equation. Okay, so y equals 1/2 x minus 1. Let's do that same exact thing but this time doing a perpendicular slope. So, step 1, find the perpendicular slope. So if we had a positive 1/2 slope, our opposite would be, instead of positive, it's going to be negative. Instead of 1/2, it's going to be 2/1, or just 2. So our slope is just -2. And then step 2, we want to plug x and y in to solve for b. So plug x and y in to solve for b. So that's going to be, instead of y equals -2, because remember we have that perpendicular slope, plus b, I'm going to say 1 equals -2 times 4 plus b. And if I solve for b, I have 1 equals -8 plus b. Add 8 to both sides, I get 9. And my equation, so step 3, rewrite the equation. So we would have y equals -2x plus 9. So that would be my final equation for this perpendicular line. All right, then we have just this quick concept summary, the slopes of parallel and perpendicular lines. This might be a good screenshot if you're worried about forgetting what parallel and perpendicular mean. If you have any questions at all about this lesson, please be sure to reach out to a friend or myself for some help. Have a great day.